Welcome everyone to today's Fireside Chat. This is part of Save on Energy's Energy Management Community Initiative, and this initiative is all about supporting the development of a community of practice among Ontario energy managers. And this includes access to monthly discussion group, an online forum, through the Energy Management Learning Platform and some other initiatives. And the goal of these fireside chats is to provide an opportunity for members of the community to share some of the great work that's being done and allow others, yourselves, to ask questions and have a conversation about some energy management projects. So we do want this to be interactive. So if you have a question at any point, don't save it till the end. Please raise your hand or type into the chat or use the Q&A at the top, and we will interject or ask those questions as we go. Today, I'm really excited to have Craig Carrothers from Presstran Industries, which is part of the Magna umbrella of companies. And Craig led a major building automation system, or BAS project, to improve energy performance and operational efficiency across the facility. It was one of the first of its kind at Magna and involved extensive planning, collaboration, ongoing optimization. So I'm really
So I'm
excited
sitting in on a webinar.
to learn more about this project. So thank you very much for joining us, Craig.
Yeah, thanks for having me, Jay. Always nice to be a part of these and spread the knowledge and yeah, get everybody onboarded with good projects.
Great. Hey, and maybe just to start off, would you mind giving us a quick overview of the building automation system project that you were involved with at Presstran? Sort of, like what did it look like, or what was kind of at a high level, what was involved with it?
Yeah, it really came into fruition from trying to gain a better understanding of our HVAC equipment, and it really came down to seeing that there was a large gap and realizing then when you walk into the factory on a weekend, a lot of things are still running. You still hear the hum of equipment, even though our processes weren't running. We still had lots of HVAC load. So that's really where a lot of the ideas came from. And
Okay.
the building automation system basically is a project and a tool kit to control those units, to automate those units, and optimize them in the future.
Okay. So it was really about trying to align, the operations of the building systems with the production schedule and what the production equipment was already doing and get better control over the building system side of things.
Yeah, exactly. We did have shutdown procedures, and we our hearts were in the right place. we were trying to perform and use the equipment to their potential, but we never really had the manpower to make sure the schedules were followed rigorously. And that's really where the gap was.
Okay. And so it sounds like there was kind of this obvious thing if you'd see these systems running when production wasn't. But was there anything that kind of hinted that this was a pretty big opportunity for energy savings, or what really got this on the radar of a project to be tackled?
Mm-hmm. A lot of it came down to rudimentary energy mapping, and it really came from we knew that there would be savings. We didn't know what that savings would look like, so that was really a driving factor. When we started to really map out the usage, we did spot measurements, and we took our best guess and a hypothesis. We didn't have the manpower to go to every single unit to put an amp clamp on every phase and measure. We couldn't measure how much gas we were using. We had to go off of estimates, and we'll talk a bit, I think, later on some faults with that approach. But really what it came down to is creating that map of energy and then realizing that there is a large potential in HVAC. And I came from an HVAC background before I went into the engineering world, and really through some of that background knowledge, I knew there was opportunity. And then working with the facilities team here at Presstran, they kind of they had the same inkling of that there was problems that we could address.
Okay. And then before, maybe you could walk us through a little bit of before bringing this for approval or getting the project signed off, like what work did you have to do to kind of scope it out or plan a project like that can be quite complex in like a large facility?
Yeah, very, very complex. Lots of equipment, lots of exhaust fans. The first step was really finding our desired state, where we wanted to be in the future, and then working towards that, building the information towards that goal. I was up on the roof for quite a while, probably about a week's worth of time up on the roof, mapping out, measuring where the units are, what our current labeling system indicated, what the unit did, what it was supposed to do, doing those spot measurements, and then really, pulling out some AutoCAD skills and mapping it all out, creating a list of equipment a list of equipment that we wanted to control, deciding why or why not we wanted to control a fan or not, and really what that came down to is we decided on a size, um,
Mm.
and then throughout the building automation system we ended up actually idling anything that we didn't control with the building automation system. But that was kind of a learning process. We had lots of fans that were on that we really didn't need to have running, and some of that came from doing the homework up front, spending the time understanding the system. Um, a large benefit was doing a in-house air balance study and measuring what the equipment was rated for, what it was uh, exhausting or pulling into the plant, and then syncing up for a desired state, what makeup air unit we wanted associated with what fan to really balance that plan out so we wouldn't have an absolutely huge negative or positive pressure. Um,
Okay. So it sounds like a
so
pretty detailed process to get that understanding of how the plant operates. Like how long did that whole piece of work take?
it was done over a couple months. Yeah.
Okay.
Yeah,
Okay.
everybody has a busy schedule, so we work towards it. I spent a lot of time, like I said, probably a week's worth or more on the roof mapping things out. And really, that's what you have to do. You got to go and see what's actually going on in the plant. So
Right. And did that lead to any, like you mentioned that there were some fans that were running that really weren't needed. Were there any other kind of surprises about what that baseline was or how things were operating?
yeah, really, what it came down to was denoting the difference between a process exhaust fan and a building exhaust fan.
Mm.
So in my case, Presstran does a lot of spot welding and some MIG welding. So, and then we have a stamping, a press shop at the back end of the plant. And what it came down to was denoting um, if a fan with some ductwork served the process, venting a process, we actually changed the nomenclature to reflect that. So we changed things to process exhaust fans, and we changed that, and we changed other fans to building exhaust fans. And then those building exhaust fans, we want to schedule. The process exhaust fans, we want to actually interlock with the process itself. So it can be hands off. No person actually have to turn on or turn off a unit. It happens automatically through the PLC.
Okay. So getting that really sort of detailed map of how these
Hmm.
different systems work and are integrated in that.
Yep,
Okay.
exactly.
Oh,
So
that's
we ended
interesting.
up with a cascading kind of interlock. So a process exhaust fan will come on. Sorry, let me take a
Mm.
step back. A process will come on. It will turn on the process exhaust fan, and then that process exhaust fan will turn on the associated makeup air unit.
Oh, okay. Okay. So they're all directly controlled like that.
Yep.
All right. Before we move further, I did notice that I think the chat might not be working, but if anyone does have questions, please use the Q&A feature. So there's a button at the top. You can put your questions in there, or just raise your hand if you want to speak up if you have a question for Craig as we go along. So you're mapping out this system and you're getting a good understanding of what you want controlled or how things should be running. Was there anything that you needed to do as part of that process to get support or to build support or buy-in for actually, before my question,
Yeah, I see a hand.
I'll pass it to Shailesh. Do you want to come off mute? You're still on mute there, Shailesh, if you want to.
Oh, sorry. Yeah, sorry.
Yep.
My laptop was on mute, but anyways, so yeah, hey Craig, so I just have a quick question there. So the fans that you guys have automated, were they like manually on all the time before, like, or how was the setup before you guys automated that?
Yeah, basically we had a shutdown procedure. They're supposed to be shut down on weekends, but very rarely was that happening. Occasionally you'd come in. I would do audits on weekends, and I still do audits on weekends to see what's running, what's not. But I consistently would see the shutdown schedule neglected. So yeah, base case was almost all the exhaust fans were running.
Oh, and so when you automated those, what happened with the air balancing? Were there any issues with the balancing?
No, that's why we did that cascade interlock. So we mapped out beforehand with a air balance study that we did in-house. We used the anemometers, went around to all the fans to measure them. And then we before we even commissioned or anything, before we even quoted really the building automation system, we created a desired state that we wanted to get to, and we basically created a spreadsheet that said, here's on one column, here's exhaust fans, here are their total CFM. Next to the column, here's makeup air unit, here's the CFM for the makeup air unit. Do they balance when those fans are? And really, I guess part of maybe you picked up on a miss there, but what we did is if there's like a reverse feedback. So you turn on the process turns on the process exhaust fan, that turns on the makeup air unit, and then when that cascade happens, there's like a block within the building automation system that then turns on the remaining exhaust fans to balance that makeup air unit out. So the system will always stay in balance unless there's a problem.
Right. So in doing that, it actually like corrected the air balance of what was currently in the facility.
Exactly. We were quite a bit negative in the winter where and we were installing other measures as well, like air curtains, and we wanted them to be optimal. So we this went a long way to contributing to other projects as well.
Okay. So reducing that negative air pressure in the facility, that would have a lot of the knock-on energy benefits as well.
Yeah, exactly.
So on the note of the benefits coming out of it, was there anything you needed to do as part of that process to get support for the project or to get buy-in to move forward with it?
Yeah, that was a really tricky piece. So we developed the scope of work. We made all this effort over a few months. Went out to tender and really before the getting support piece came out, we wanted to have a really robust quoting process. So and really there was lots of information that we didn't have that we didn't know going into trying to create a desired state. So went through a very extensive quoting process to find 4 vendors that we would be happy with. And then we did a quality function deployment, and we actually found out what we wanted, what we needed, made a bit of a matrix, and I'd recommend looking at QFDs if you ever really want to try to find a less biased approach at vendor analysis. But anyway,
QFD is a QFD.
Yeah,
is
QFD. Yeah, quality function deployment.
okay.
Yeah. So just a technique that you can really find out what you want and what you need and what the correlations are between um, the benefits that you're looking for.
Okay.
So, and then you can cascade it down. But anyway, through this robust kind of quoting process, we developed some good relationships with our vendors. So we had the ability to answer lots of questions, and then we're very transparent in that quoting process as well, where we basically, if anybody asked a single question, we would give that question to everybody with the answer as well to everyone that was bidding on the project. And then so we developed this good relationship. We developed a good analysis on why we chose that vendor. So that really helped strengthen our position with trying to get approvals later on.
Right.
And then the next set of approvals was Magna's Industry 4.0 initiative, and that was another set of hurdles that we had to try to adhere to. And really this it didn't, I guess we'll say it slowed it down, but really it strengthened why we needed to get a building automation system, and it really made us develop a good understanding of what we needed to do for a final project. And throughout that approval process, there was lots of give and take and to try to satisfy everybody's questions, and ultimately we did get approval. The project did start about 8 months after we submitted approval, but it did go ahead.
And what is the, can you give some details around what that Magna 4.0, Industry 4.0 is looking at as part of that approval process?
Really just vetting that we're not storing the information improperly, meeting the security guidelines, and then also
So it's all about sort of that data, cloud management, Internet of Things approach.
Exactly. Yep. Trying to make sure that there'd be a good solution that we're not going to immediately have to replace in 5 years when a different solution comes on. Making sure that we have APIs available to connect to other systems.
Okay.
Yeah,
So that it would
that's
be
really
compatible, like forwards, backwards compatible, and all of that.
Yep, exactly.
Okay.
There was a I guess it wasn't well understood what BACnet IP was for communication protocol in the industrial world. A lot of IP protocols, but Ethernet IP. But BACnet was something a little bit new to some of us. So that was also part of that Industry 4.0 hurdle.
Mm-hmm. Yeah. And then the other thing I'm curious about is that I know that in automotive, sometimes there's very low thresholds for payback of energy projects. And at the same time, something like metering or a BAS that doesn't necessarily have direct savings. It's a tool that can lead to savings. Sometimes the business case for that can be challenging. So I'm curious, like, how did you approach that, or address some of those challenges, or get the comfort that this was, the business case for this was solid?
Yeah. Very interesting question, and a lot of back and forth on what we would want for metering. What we ended up going with is using CTs on all the pieces of equipment that we would be controlling with the building automation system, and it turned out that we controlled everything. Anything that we didn't control is now idled. But we put CTs on everything. That way we would have both the trending and measurement capability, but then we use those CTs as the feedback to know if a piece of equipment was running. There's always that kind of loop where you don't want to just measure the fact that you've hit on. You want to measure the fact that the pieces of the exhaust fan is running, especially when you're using like direct fired makeup air units that could potentially be putting CO into the building. So we want to make sure the exhaust fans are running. So having those CTs kind of served as double purpose. They both helped with our energy metering and our information system, but they also serve as feedback loops into our systems.
Okay. And how did you, like those CTs?
Current transformer is the.
Current transformer. So as part of the BAS, you had the current transformers to measure the energy use, not just control those systems. As part of that, in making the business case for this, how did you like the whole air balance and all these different systems? It's a very complicated, interactive system. How did you go about developing like the savings estimate or what the benefits of this project would be to support that business case?
Really, it came from a lot of different avenues. Really, it was we weren't 100% sure how to address that at the beginning. So the first step was we asked all the vendors to provide an estimate on what their system would likely to save, and then my facilities team and myself, we developed our own savings estimate with the help of local utilities to develop kind of a, we'll say, comparison piece to what we thought the vendors would be saving. That it turned out that while the savings were very similar to what we actually estimated, it was a little bit a different ratio, gas savings to electricity savings than what we thought. We ended up saving a lot more gas energy than electricity energy, but really what that came down to was needing better spot measurements and really more a better sample, bigger sample distribution.
Right.
In the desired case, basically we could measure it to see how far we were off with the use of all those CTs, and then you could actually see, okay, well, I measured this exhaust fan at 15 amps. Sure, it uses 15 amps, but then if you close a couple dampers, maybe you're drawing a different amount of current. So there was, and same with makeup air units. It was, the spot measurements were a snapshot in time. Not having the trending capability, let us down. And you know what? We did a great estimate. We've predicted about a 2.5 year payback. We probably actually were closer to the 2.1 years. So we were actually conservative with our estimate.
Right. So getting that estimate was based on like spot measurements and some estimates around like operations, duty cycle, that kind of stuff. But it got you in the ballpark.
Yep, it got us in the ballpark, exactly.
And that 2.5 year payback, was that a challenge, or was that sort of an acceptable level?
Acceptable level with that kind of capital expenditure. It is a fairly large project. There's lots of moving pieces, lots of manpower involved to get a system like this up and running. One of the huge hurdles that we actually addressed, and I credit my facilities team for coming up with this, but we actually put door contacts or used door contacts that were available for every single door at Presstran, and then have a cascading system to say if that door is kept open or closed. So if it's kept open, and measure the delta temperature between the inside of the plant and the outside temperature. So if we're less than say 18 degrees outside, it's fairly chilly. We don't want to heat the outside of the outside atmosphere with all the makeup air units. So we actually, and tube heaters. So we set an alarm at 15 minutes. It notifies all the team leaders at half an hour, notifies the supervisors, then the department leaders, and then after about a 2-hour period, goes right to the general manager of the facility to address.
And I bet he's very happy if he gets a notice that those
Yeah.
doors are being left open.
Try not to get to the 2-hour point of leaving doors open during the winter.
Benjamin, I see your hand.
Hey, Craig, thanks for talking to us today. I wanted to ask with the example you just provided, what kind of training did you have to provide to your on-site staff and your maintenance team, and what kind of resistance did you experience, in implementing this kind of system?
Less so resistance from the maintenance team. I brought the facilities team on from the get-go, and it was a combined effort between both of our knowledge base and both of our the hours that we can put in a week. It was the combined effort between the both of us that was able to drive this project. The resistance came from shutting off heaters and makeup air units that we had used to heat the plant. Shutting off those units in the winter is challenging. We're using tube heaters now for the most part to heat the facility. They provide a good cone of heat, but if you don't have them in specific areas, and now we're not heating the air, there could be cold zones, and really that's what we're trying to address and fix now. We have 25 forklifts driving around Presstran, and they all put out about, say, 80,000 BTUH. So those kind of heat the facilities. We're trying to go electric, so that'll be another hurdle. But really, the resistance came from that lack of knowledge, like you said. The training piece, we actually had that built into in the quoting process. We wanted anybody who would have access to this system, we wanted to be trained by the vendor themselves. And then we had a hierarchy system of access. So if you log in with your username and password, depending on your position, what you need access to, you'll have access to only a certain part of the building automation system. And then we rolled out training from then to address that piece. So say for security, somebody's coming in on a weekend, they will call security. Security can then turn on their rooftop unit associated with their area, and then their lighting as well. If it's a scheduled overtime, there's an overtime meeting on Fridays, then we actually schedule in the building automation system who and where we need HVAC and lighting. Really, when you're creating these systems, it's to your benefit to use it as a tool. So you really want to work closely with the integrator on developing the building automation system, and then at the end of the day, you'll be the expert at using it. That's how we try to deploy it. So myself and the facilities maintenance team, we're all fairly well versed with using it, and its different capacities, lighting, HVAC. Yeah.
And having like the team in those different levels gives some resilience too. Like I've been in facilities where, we're looking at the BAS and we're like, oh, can you, like, this seems weird. Can you tell me what's going on? And they're like, well, the person who knew this left 3 months ago. So.
Yeah, exactly. Yeah, having multiple teams of people actually being able to use it. And then have those teams be energy conscientious enough to use it correctly. That may be a trickier piece. Thankfully, I didn't. I got fairly lucky. My facilities team is quite wonderful and enjoys the energy management challenge. So they were on board from the get-go.
We also have a question from Mohammed about what applications or software do you use for the BAS, and is that integrated into an energy management information system as well, or do you have separate applications for those?
Um, it is integrated into an energy management information system, if you want to call it that, but that is our whole Industry 4.0 system. So
Oh, okay.
it is integrated into that through an API. The software that we actually use is IntelliWeb-based software, so it's a like HTML-based web coded software. Delta Controls is the actual provider of the equipment.
Okay. And you talked before about having the matrix and choosing them. Were there any, like, what were your top priorities, or how did you kind of decide what was the important stuff to evaluate those different proposals?
Really what it came down to is and what I find a lot of projects come down to is the competing priorities between energy management and maintenance.
Mm-hmm.
So you want to build a nice, robust system. Chances are you're going to have to sacrifice a little bit of energy savings to build in that robustness. So those were our competing priorities, and really we scaled them very, very similar when we're actually doing the analysis. I think in the spirit of actually using in the spirit of conducting this project and getting it done, we slightly gave the edge to energy efficiency, but really the maintenance and another one was actually maintenance service. Having the ability to, if there's ever a problem with the building automation
Okay.
system, this is a critical piece of infrastructure for Presstran. We need it to work if we're going to actually build car parts. So
Right.
service was up there too, with maintenance, service, and actual energy savings. Those were the kind of three critical elements.
Okay. And we have another question in the chat about if you're able to share what CTs, like make models you use, or if you have that information. And then are those hardwired or wireless transmitters or internet? Like, how is the data
Yeah,
communicated?
that's an interesting question. And one that everybody who has to install a building automation system will have to face, whether or not you think it's worthwhile to do wireless or a wired system. And that'll really come down to your IT infrastructure as well. Our IT infrastructure on the roof, really we never had a need, and we don't have a need to have IT infrastructure on the roof. So our signal capabilities up there are limited. So we decided to go with a wired system for everything. So, and then really daisy chained as much as we could. We had to be careful with the architecture and network architecture. A lot of our units are daisy chained. We did have I believe, a 3-controller limit on how many were daisy chained, and then as a backup, the Delta controllers actually continue to run off their last programmed instruction. So if they're scheduled, they'll maintain a schedule. So limited amount of risk there. And I encourage you to dig into your network architecture to make sure that you can limit the risk for these systems. They are critical pieces of equipment. So.
And do you know what were the CTs that were installed?
I don't remember off the top of my head. I believe they were a Greystone manufactured CT. Not really. As long as you find a CT split core or solid core with 4 to 20 milliamp capability, they're probably very similar.
Again, back, so after you gotten the approval from all those different levels, when it comes to implementation, like you have a 3-shift operation there, or when this was going on, how do you manage the installation of this system around your operations?
Yeah, that's another very so going back to that bidding process. Those are the questions that you really have to ask and get a understanding of what your integrator's capability is, because it's going to be a challenge. We have a very it could change on a moment's notice, basically our production schedule. So if we scheduled in a line to be run over a production machine and then they need that line, we needed to be able to tell the team that was working above that line that they needed to move to a different area of the plant. So it took a lot of coordination. That was by far the most challenging part of the project, was exactly that, trying to move people around, and then come back to remember where you were to continue to install. It's a critical piece, and really you're going to have to understand your integrator's capability and build that relationship with them so that it's not it doesn't just become an absolute headache, because it even if you have a very easygoing vendor, it's still a very challenging very challenging coordination effort to make it happen.
And were there any strategies or approaches to kind of work around those areas where you might have limited availability, or create windows of availability?
Make sure that, so the way we had it quoted was that there was a certain percentage of weekend overtime work. Really, that I don't see another way around it. Very difficult in a lot of production facilities to have any competing priorities with production. Production is where value is added. So these support systems are going to take a backseat to them every time, and you have to be willing and understand that. So my recommendation would be prioritize a few key areas that you want. Say, get all the makeup air units up and running, and then, as much as it's going to cost a little extra, maybe have a couple different scissor lifts available so you can rapidly change where you need to go.
Okay. And during implementation, were there any surprises or hiccups that came up?
Oh, for sure. Even with coordination, coordinating with your production team and then them saying, no, we have that for an hour, you can switch over, get the shut down the exhaust fan, then get it back up and running with the building automation system. Then 15 minutes later, they say, no, we need that machine. That can be challenging. And then trying to work with your electrician and vendor to try to get that exhaust fan up and running as fast as possible. That can be tricky. Another challenge is basically there's going to be opportunity to understand your system, but you're always going to find things that you didn't expect. We found a few units that had been decommissioned, that we had included in the scope of the project, that I had seen working but were technically decommissioned that shouldn't have been running. So you find surprises, and you gotta work around what you gotta work around and be flexible and really make sure that you're coordinating well with your team and your vendor, because it's tricky.
Were there any challenge, like bringing in a new control system into an existing building, existing equipment, sometimes older equipment? Were there any sort of challenges that arose from that?
Yeah. The biggest challenge was being able to shut off the makeup air units and have them turn back on, especially when commanded. very, very challenging. What we ended up doing was working with our HVAC service provider to create a matrix of required components and components that we knew we would have to change, and ones that kept coming up over and over again that we knew were going to fail, have them readily available where we're kind of in the commissioning process and even post-commissioning process where we're understanding the capabilities of the makeup air units. Lots of dampers being frozen, lots of burner plates being cracked and not necessarily having the most reliable units. You got to remember that these units would have been turned on and just left on all winter long. They wouldn't turn off very often at all. So, and really that's where the savings comes from, turning these things off, right? So they're problems that you have to address. The best bet that we found was work through the issues. Shut them off, turn them on when you wanted, find out what's broken, record that information so you know for other units what's likely to fail, and then rinse and repeat, and can continue to work through those issues. And then as far as controls, makeup air units they can be controlled at 4 levels with a thermostat, or they can be controlled through supply air temperature. What we found was if you control it at the thermostat level, you'll get people playing with it, and you'll get the makeup air units used as big furnaces. They'll be used for space heating applications, not necessarily just to make up the air that you're exhausting and the heat that you're exhausting. So we found that just controlling the supply air temperature to a comfortable degree took away a few headaches. So now we just have the makeup air units come on through that cascading interlock system, and basically spit out a constant stream of comfortable temperature air.
Mm-hmm.
So yeah, those were by far the biggest challenge, was the makeup air units and having them be reliable.
Right. And then, like you mentioned, that the process where like doors are left open, and then the notice gets sent out, and that gets escalated. You mentioned before that like a BAS itself doesn't save energy; it's what you do with it. It's that tool.
Mm-hmm.
Were there any other examples of processes you put in place to make sure that the BAS was being used to, like, actively as a tool that people were using it to save energy?
Yeah, really 2 parts to that. One, restrict access as much as you possibly can. only have yourself and a team that you can rely on, who are energy conscientious. Try your best to do that. I know it's not going to be possible in every application, and you're going to be asked to turn, even if you can get that, you're going to be asked to turn on exhaust fans that you might not necessarily want turned on. Really, yeah, it's you're yeah, you're gonna have to struggle through some of those things, but there's no easy way around it, Jay. I guess
Right.
it's I wish I could tell you that there was a foolproof method, but yeah, try your best to limit the ability of it not to be used incorrectly. Try to, when you're using it, try to optimize it, and then get everybody encouraged to, oh yeah, like let's do this next. Like keep the encouragement going. Yeah. It's hard. That's a hard question, Jay.
Yeah. And what kind of, like, what results have you seen from it so far in terms of savings or other benefits?
Yeah. Basically cut our gas bill in half, maybe a little bit more than half, and fantastic energy savings. It's hard to say because business conditions have kind of affected my cumulative sum analysis through linear regression, but so it's kind of skewed a little bit. But I would have to say we're probably in the at least 1,000 megawatt hours. I would say
Wow.
over the course of say a year and a quarter, year and a half. Not quite as much as I was hoping for 2,000 megawatt hours, but we're still optimizing. There's still lots to be done even now. So
Okay. And
yeah, and like I said before, 2.1 year payback on a very expensive project.
right. That's great. Have you noticed or seen any other benefits beyond just the direct energy savings? Like I know sometimes like the data can be useful in terms of production or maintenance or other areas. So have you seen any other benefits coming from having this control and this information?
Yeah, for sure. Our makeup air units are more reliable now than ever. We don't have issues like we did in the past where turn on a makeup air unit to try to space heat and it no longer works. We've idled and understood better, idled units and understood better where heat is needed, which is good for comfort heating. Understanding better, serving the operators and Presstran personnel. We understand the facilities better, so we're getting more and more comfortable environment all the time. There's definitely a condition-based monitoring approach to maintenance that's a big win. Now, when we're seeing variances in CTs in our amperage measurements from those current transformers, we can actually go and investigate whether the fan's malfunctioning or in some cases broken or a belt's broken or lots of different condition-based monitoring elements. It'd be nice to have, we'll say, more accurate figures like vibration sensors for condition-based monitoring, but it's a huge step forward into the maintenance methodology. So that's a big win too.
And we have a question from Neil if the system has remote access. So if you want to, control it from your house or cottage, for example.
It does have remote access. You have to, because of our Industry 4.0 initiatives, we can VPN into the Presstran network and access the building automation system remotely.
Okay, excellent. And looking back at that whole life cycle of the project, what do you see as some of the key success factors of the work that put in to lead to such a great result?
Yeah, biggest win was having the system mapped out, actually being able to understand what's required, what's not required, when fans should be turned on, what fans are associated with what processes, dividing out building fans from process fans, and then assigning those to certain makeup air units. That was a huge win. That alone saved money. Just spending time and effort. That alone was a good opportunity that even if you don't install a building automation system, I would encourage to spend the time and effort to do that. Another big win was really building the encouragement to get the system approved and giving more people the understanding of why we're doing this building automation system, and having that more people get a familiarity of what makeup air units are supposed to do, what exhaust fans are meant to do, especially the piece where makeup air units aren't they're not designed or meant to heat a building. They're just meant to make up the heat lost by exhaust. That's a huge piece of the puzzle.
Right, just getting the better understanding of it.
Yeah, that alone is a great win.
There's a question from Al in the chat about what about ownership of those makeup air units? What group was responsible for maintenance before the project, and did it change after the project? It sounds like he's had some experience with no one owning the rooftop HVAC
Mhm.
units in a plant?
I don't know if you have a facilities maintenance team. It should be a maintenance function. They're assets that um, are 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 critical assets to the building and the operation of a building. They should be maintained. There should be preventative maintenance done on them. You should understand the failure modes of them. So it, it should be a maintenance function.
Okay. And were there any changes, or was that sort of consistent before and after
Um,
your project?
yeah, the only still a facilities function before and after. The only piece was me being attached to it, and me kind of auditing the processes and make sure it's operating correctly and the way that it was designed to run. I guess that's really the only change.
Right.
I still get
And
bugged to turn on exhaust fans that are off, but
yeah,
yeah.
and Al followed up and said that yes, but it was like, I guess the makeup variants are typically low priority versus operating equipment. I'm not sure if you know
Yeah.
anything like in terms of bringing more visibility into their operation. Has that changed at all?
In our operation, we need to maintain, and in your operation, you'll need to maintain a certain temperature within the facilities, 18 degrees Celsius. So they should be critical pieces. If you were exhausting a lot of air, you say you had a paint shop, or you're welding, I'm not sure what your facility does, but if you're exhausting a large quantity of air, they are critical pieces of equipment. So very high priority. If you're not exhausting a lot of air, I could see the lower priority, but you should still maintain some ventilation effort because you're probably dealing with some sort of chemical within the facility that if you need to exhaust, you're going to run into an issue where you need to heat the building with a large amount of air. Um, make up the building with a large amount of air, and that air is going to require heat.
Okay. And I think we have one more question from Neil on, besides the plant, do you have office space attached? And um, does the office space in the plant work on different schedules? And how might you manage that?
Yeah, yep. We have few office areas attached to the plant. They're run with like a VVT system through rooftop units. They're scheduled. So building automation system has two sides to it. One is process automation, and then the other is a scheduling capability. So and that's really the piece where we're like, if you say you're coming in on a weekend, you're going to call security. Security is going to turn that rooftop unit on for you, and it's going to get to the set point. Ideally, you call them on the way in, so it's not cold when you're in. But it's gonna you're gonna control those through a schedule, and then we have security trained to basically create. They're like a single event in a schedule that you can have associated with a piece of equipment. So security is trained to create a single event. You have to tell them what exhaust fan you want, what lighting you want, and then they'll be able to arrange that for you. So your office space is heated and lit.
Okay, so they can be controlled on different schedules.
Yep.
Okay.
Yep.
And then a question from Mohammed in terms of, are there any key aspects that need to be checked at the design commissioning phase based on your experience, other than ensuring that a robust BAEM is in place tracking all energy and media? So yeah, anything like any critical things to check on that, the design and commissioning?
Really, you're looking for maintenance items, and then you're looking for reliability of your dashboard system. So you want to go through and make sure that every single unit interlocks correctly. You want to make sure that every single unit command, the command structure is operating correctly. So say I turn on I spoof a process, you want that cascade to work. And then at the end of the day, you want all those current transformers to read back to you saying those units are on. If you want to go one step further, I would I would measure each phase of if you're like a 3-phase 600-volt system, measure each phase to find a good phase to put the current transformer on. That could be another one. Less critical. What else you want? All the scheduling features and lighting you want to be running. Training is another critical item. You want to make sure that your security team or whomever is going to be scheduling last minute items, you want to make sure that they know exactly what to do, that there's no hesitation. And making sure that if there's a hierarchy of control, like say I was the security operator, I had access to the rooftop units and lighting schedule, that separate page works as well as the administrator page. You really have to be careful with making sure that control structure is operating correctly. And then once again, that's a go and see element. Make sure you turn something on, go walk out there and make sure that the makeup air unit's turning on correctly.
Right. So in the
or a
commissioning,
exhaust fan or whatever.
right. So when you're in the commissioning, make sure you're actually going out and seeing it with your own eyes, sort of stuff,
Yeah,
and not just
exactly.
trusting the system. Okay.
Yep. I can't recommend going and seeing enough.
All right, great. Well, thanks. We're just about at the end of time here. So again, thank you very much for joining us today, Craig. This was a great discussion. As always, to everyone else, we really appreciate your feedback on these events that we're doing. So I put a link in the chat. If you could please click on the link and fill out the form. It is 4 very short questions, so it should only take a minute or 2 to fill out, and we really appreciate that. A couple of last announcements. Applications are now open for the 2025 Energy Management Excellence Awards. Craig is a previous winner of these awards. You could be too. So please you can use the QR code or go to the Save on Energy website. The address is on the screen there to submit your nomination. So it's open to all Ontario facilities. We're looking for exceptional energy management projects from 2024. Past winners and applicants are welcome to reapply, and the ceremony will be taking place in September of this year. Again, if you want to keep the conversation going, please join the energy management community. This gives access to peer learning opportunities like the Fireside chats and discussion groups, the Spark, and it also gives you access to the Energy Manager Learning Platform, which has online courses, resources, and a discussion forum. So if you have any more questions after today, you can go onto the discussion forum and ask there. And if you haven't already registered for it, I will drop a link in the chat to register for it. It is just free. You just have to fill out the form. And next announcement's coming up. We do have an in-person event. This is a community in action at Sick Kids Hospital at the end of the month, where we will be having a live practice session where you will get to practice working on improving your business cases for energy efficiency projects with our coaches and with peers. And we have more content coming up on the learning platform as well. So thank you everyone for joining us today. Thanks again, Craig, for having us, and have a great rest of the week.